Hey everybody, in this video I'm going to be showing you how we build the unit circle, how we can use our special triangles that we've studied in the past to figure out the sine and cosine of all of the values in quadrant 1, and then how we can use what we know about reference angles to take the information from quadrant 1 and build the rest of the unit circle. So today I'm going to be talking about the unit circle and building it and creating all the coordinates. So what I want to look at is, here's the definition, is that the unit circle is a circle with a radius of 1. So that's listed right up here for us, that the radius from the center to the edge of the circle, that line segment, has a length of 1. Now that's made up of an x coordinate and a y coordinate. X is how far left and right that point is from the origin, and y is how far up or down that point is also from the origin. We would just measure it over here on the y-axis. Now, when we first talked about our trig functions, we talked about SOHCAHTOA. So here, if this is our angle theta, x is our adjacent side, y is our opposite side, and 1 is the hypotenuse. So if we're trying to fill in our trig functions here, sine is opposite over hypotenuse, which in this case is y over 1, or just y. The sine of theta is always just the y coordinate. To find cosecant, we would just flip that. So if the sine is y, the cosecant is going to be 1 over y. Cosine is adjacent over hypotenuse. Remember, I'm going to write it up here just so we don't forget. SOHCAHTOA. So cosine is my adjacent over hypotenuse. In this case, my adjacent is my x coordinate, and the hypotenuse is still 1. So the cosine of theta is always just the x value. I'll even write it in red. It's an x value. Cosine goes with x. You can remember because they're alphabetical. C comes before S, X comes before Y. So the cosine is X. If we needed to find secant, we would just take that X value and put it under 1. Tangent's a little different. Tangent, we've got opposite over adjacent, which in this case is Y over X. Or as I like to remember, what I find to be really helpful is that it's sine over cosine. Those are the 3 ways you can think about it. Tangent, we would do the opposite of that. We would take, instead of y over x, we would do x over y, which is the same as cosine over sine. The coordinates of P can be written as cosine, which we said was x, comma, sine, which we said was y. So now that we know how the coordinates relate to this unit circle with a radius of 1, what we need to do to put this all together is to know that the unit circle is used to map the angles of 30 degrees, 45 degrees, and 60 degrees, and their multiples. So as you can see on the unit circle, we've got 30 degrees, 45 degrees, 60 degrees, and their multiples. So multiples of 30, 30, 60, 90, 120, 150, 180. It goes all the way around. It also is going to look at these coordinates that are on the axes, which are going to be our 0 and 360 degrees, 90 degrees, 180 degrees, and 270 degrees, which are the quadrantal angles. So I'm also going to put in here, we've got to know these in terms of radians as well. So 30 degrees is our pi over 6, 45 degrees is pi over 4, 60 degrees is pi over 3. Here we've got 0 and 2 pi. Here we've got pi over 2. 180 degrees is just pi. 270 is 3 pi over 2. So we want to make sure we know those in terms of degrees and radians. The nice thing about the unit circle is I'm going to show you in the next slide how we're going to build specifically quadrant 1, but then as long as we know quadrant 1, we can build the rest. So there's a nice little trick to help you remember all of these sine and cosine values. Okay, so here's our first special triangle. It's a 30-degree angle or pi over 6. So if you guys remember when we have a 30-degree or 30, 60, 90 triangle, we have the special relationship of the sides that we create from there. So that is our x, 2x, and then the x square roots of 3 that we can build from a 30, 60, 90 triangle. So that's the first one we're going to build. Just as, to keep you guys reminded of your radians, 30 degrees is the same as pi over 6. So we can be talking about it either as 30 degrees or pi over 6. I'm just going to leave it as 30, 60, 90 for now. So the special thing about the unit circle and the reason why it's so important, the reason why we can use it so beneficially is that it is a specific circle that has a radius of 1. Since we have a radius of 1, we actually know one of the sides on this special triangle, and that's our 2x side. The hypotenuse goes from the center of the unit circle out to the edge of it. So that side on the unit circle is equal to 1. Some of the practice that we did a little bit ago was to say, okay, well, if we know the length of one of the sides, then how can we solve all of the sides? Well, in this case, what we're going to do is we've got to get that x value by itself so we can fill in the other sides. So if we know that 2x is equal to 1, when we divide both sides by 2 to get x by itself, we know that x is equal to 1/2. So this side over here, across from the 30-degree angle, our short side, that x value is 1/2. The length of that is 1/2, just as our hypotenuse is 1 for this triangle. So we've got 1/2 and we've got 1. Now we need to solve for the third side. So x squared of 3, I'm going to plug in that 1/2 that is x in for x to give me 1/2 times the square root of 3 over 1, which when I multiply that through is the square root of 3 over 2. Let me change that to red so I can highlight it in for you guys. Square root of 3 over 2. So now in this 30, 60, 90 triangle, we found the length of these three sides. We found that the height of the triangle, which was originally our x side, but the height we know is actually our y value. The height is 1/2. And then the length of the side on the x-axis, or the x value, that x length, is actually the square root of 3 over 2. So just by knowing our 30, 60, 90 relationships and our ratios, and the fact that this special unit circle has a hypotenuse of 1, we can find the x and y values of that point, of that coordinate, which is just what we did. So in this case, the x length, as we saw for, is the square root of 3 over 2, because that is this bottom side down here. And 1/2 is the height. That's our y value here. So now we have our full point of 30 degrees on the unit circle has an x coordinate of the square root of 3 over 2 and a y coordinate of 1/2. So now we're going to do the same thing with our 60-degree angle, or pi over 3. Again, this has a radius of 1. So I'm just going to draw on the triangle because that's what we're going to use to solve here. So here's my triangle based on that point. I've got my x side and I've got my y side. But what we're going to use is that special 30, 60, 90 relationship. If this is my 30-degree side, then I know that the side that's across has a length of my ratio of x. The hypotenuse has a length of 2x for the ratio, and that y side has a ratio of x square roots of 3. So I know that 2x is equal to 1. 2x is equal to 1. My 2x side is equal to 1. So for my ratio, I know that x is equal to 1/2, which happens to be our short side over here. So the long side is 1, the hypotenuse is 1. The short side is 1/2. And my long leg I'm going to plug in a 1/2 in for the x, multiply it by the square root of 3 over 1, so I end up with the square root of 3 over 2. My y side, this side, has a length of square root of 3 over 2. My x side has a length of 1/2, and my hypotenuse has a length of 1. So if I were to write this coordinate, that x length, that x side goes out to 1/2, and my y side, if I were to measure that over to the y-axis, comes over to the square root of 3 over 2. So for a 60-degree angle on the unit circle, it has the coordinates 1/2 square root of 3 over 2. Then lastly, for quadrant 1, I have my 45-degree angle. If we draw the triangle that looks like the bow tie out of that, if one side is 45, sorry, one angle is 45, we know that the other that isn't the right angle is also 45. And then in that triangle, those are related as x and x square roots of 2. Those are the ratios that I know I have in a 45, 45, 90 triangle. From there, what we have to ask ourselves, what do we know? Well, we know that the radius, the distance from the center to the edge of the circle, is 1. So x square roots of 2 is 1. I can write an equation. But what I need to find is what is that x value. So I'm going to divide both sides by the square root of 2. So x is equal to 1 over the square root of 2. Now we know our rule, we can't have a radical sign in the denominator, so I'm going to have to rationalize. I'm going to multiply by an equivalent of 1. If I divide square root of 2 by itself, that becomes 1, so I'm not changing the equation. What I end up with here is 1 times the square root of 2 is the square root of 2. Square root of 2 times the square root of 2 in the denominator, the square roots cancel out and I'm left with 2. So my x is square root of 2 over 2, because that's what I solved for using my ratios. The nice thing about a 45, 45, 90 triangle is that if I know one leg, I also know the other leg because they're the same. So the coordinates for a 45, 45, 90 triangle are the same. I've got the square root of 2 over 2 for my x and the square root of 2 over 2 for my y. Okay, so now we've built our 30, 60, and 45-degree coordinates. Now what we're going to do is fill all of this in, but as we do it, we're going to talk about why we only need to know quadrant 1. If we know quadrant 1, we can build the other ones and use reasoning without having to go through and try to memorize the entire circle. So I'm going to start by filling in x and y coordinates of the easiest pieces that we can do, and those are our quadrantal angles, our 0/2 pi, pi over 2, pi, and 3 pi over 2. These are easy because they're right on the x and y axis. If we know that the radius of our unit circle is 1, then the length of this side, or the distance that it's going in the x direction, is just 1. And we haven't moved up or down at all, so that's a y value of 0. If we look at pi over 2, again, this is a length of 1, but now we have to say to ourselves, what direction is that in? We haven't moved left or right, so we don't have a different x value, but we have gone up a length of 1 in our y direction. Pi is going to feel very similar to 0 or 2 pi, but this time we're going to the left. Since we've gone to the left, we're affecting that x-axis, the x value, but now it's going to be negatively, and we have not moved up or down at all. 3 pi over 2, same idea. We are a unit of 1 away. We've changed our y coordinate. That's going to be -1, but we have not gone left or right, so our x value is still 0. Okay, so we've got the quadrantal angles filled in. Now we have to look at the other angles. We're going to focus first on quadrant 1 that we've already built. If we start with our 30-degree angle, let me build that triangle over here for you. So this is my 30 degrees. We know that the radius is 1, so that's the distance from the center to the outside. This is the point we're looking at. We're looking at this point right here, but we can build that triangle from it. So if we've got our triangle here, the radius is 1. The cosine, the x distance, was the square root of 3 over 2. And the y distance, that y height, was 1/2. We built that already, saying that our x coordinate is the square root of 3 over 2, and our y coordinate is 1/2. Looking at 45, 45, 90, same idea. We knew that the radius was 1, and by figuring through, we figured out that both the x and the y values were both the square root of 2 over 2. Okay. For our 60-degree angle, again, radius is 1. Our y value is the square root of 3 over 2, and our x value, we're looking at this point, is 1/2. 1/2 square root of 3 over 2. Now, I'm attaching another link in Google Classroom, so be sure to check that out. There's a thing called a left-hand trick to try to memorize those things, those coordinates. So it's super fun, but someone else explains it better than I probably could. So go check out that video. It'll help you remember. The other thing to think about when you're trying to remember which coordinate goes where, the square root of 3, I'll write it over here, is about 1, it's 1 and some more. It's bigger than 1. So the square root of 3 is bigger than 1, which means that the square root of 3 over 2 is bigger than 1/2. If you're looking at the unit circle, let's say we look at 60 degrees, we can see that that y value is bigger than the x value. You can see that that long leg, we know that this is the long leg, the one that's across from the 60 degrees. That's longer, that's taller than the x value is wide. So the square root of 3 has to go in the y coordinate, and the 1/2 has to be the x coordinate. If we look back at 30 degrees, so it goes right here. If we look at 30 degrees, you can see that the x leg, this leg right here, is longer than the 1/2, than the leg going up for the y. The x is longer than the y. So the square root of 3 over 2 has to go in for x, and the 1/2 is going to go in for y. So just a little trick to help you remember which goes where. The nice thing is, once we know quadrant 1, all we have to do is reflect what we've done to find all the other quadrants. So I'm going to pull up some new colors here. Let's look at 30 degrees first. If you look at 30 degrees and we draw a horizontal line all the way across, 30 degrees has the same y value as 5 pi over 6. Since it has the same y value, it's going to have the same y coordinate. That is also going to be 1/2. We can do the same thing with x. I'm going to drop a line straight down, and what you're going to see is that that line straight down goes through 11 pi over 6. These 2 points have exactly the same x value. That's our square root of 3 over 2. Okay. Interestingly, 30 degrees, or pi over 6, is the reference angle for 330 degrees, or 11 pi over 6. If we look over here, we're looking at 5 pi over 6, or 150 degrees. The reference angle for that is 30 degrees. It's 30 more degrees to get to 180, or pi over 6. It takes one more pi over 6 to get to pi. So if we know the coordinates in quadrant 1, we also know the coordinates in all the other quadrants. This x value is actually the same as this x value, except it's in the negative direction. So if the x value of 30 degrees is the square root of 3 over 2, that means that the x value of 150 degrees is the square root of 3 over 2, but we've gone to the left, so it's negative. I can do the same thing. I can drop a line down now from 5 pi over 6, or 150 degrees, that x value is exactly the same, negative square root of 3 over 2. And in this case, we're going down the same distance. This is the same distance as this, so it is 1/2. It's just negative 1/2. I can again draw that line across here to my 11 pi over 6, or 330 degrees, and I'm going to have that same y value. It's still negative 1/2. So we've already built 3 other of the coordinates outside of quadrant 1 just by using these reflections. What's kind of neat is usually if I do it in class in front of y'all, I end up with paint and I fold the paper to show you that those x and y coordinates are exactly the same. I have to kind of do it with drawing here. So sorry for not having that. Let's take a look now. Let's see if we can fill in the rest. So pi over 4, or 45 degrees. Any angle along the throughout the unit circle that has a reference angle of pi over 4, or 45 degrees is also going to have these coordinates, just positive or negative depending on where they fall. So those values are 3 pi over 4, that has a reference angle of pi over 4, 5 pi over 4, which also has a reference angle of pi over 4, and 7 pi over 4, which also has a reference angle of pi over 4. So I can take this square root of 2 over 2, and those are my coordinates. I just have to think about what's positive and what's negative. So, So for 3 pi over 4, I've got the square root of 2 over 2. Square root of 2 over 2 are my x and y coordinates. But because I'm in quadrant 2, I've gone to the left. My x is negative. I'm still up, so my y is positive. Negative square root of 2 over 2, comma, positive square root of 2 over 2. Let's go down to 5 pi over 4. Let's fill it in. We know it's going to be the square root of 2 over 2. We've gone to the left, so x is negative, and we've gone down, so y is also negative. So there's our coordinate for 5 pi over 4. It's negative square root of 2 over 2, comma, negative square root of 2 over 2. Last one, 7 pi over 4. We're going to fill in. We know the numbers already. Square root of 2 over 2, square root of 2 over 2. We're to the right, so this time our x-coordinate is positive, but we've gone down, so our y-coordinate is going to be negative. Okay, last one. 2 pi over 3, 4 pi over 3, and 5 pi over 3 all have a reference angle of pi over 3. So they are going to have the same coordinates as pi over 3, or 60 degrees. So I can take these numbers, I can fill them in. 1/2, comma, square root of 3 over 2. We've gone to the left for 2 pi over 3. We've gone to the left, so and up. So my x is negative, my y is positive. If we look at 4 pi over 3, same numbers. 1/2, square root of 3 over 2. We've gone to the left. My x value is negative. We've gone down. My y value is negative. 5 pi over 3. Last one, you guys, we're almost there. 5 pi over 3. We're going to write the same numbers, same coordinates. 1/2, square root of 3 over 2. Don't forget, you can see it. If we drop that line all the way down, there it is. Same x value, same y value, just in the opposite direction. Okay, so we're to the right this time, so my x value remains positive. My y value, we've gone down, so that's negative. And there it is. We have built the entire unit circle. Awesome work. Okay, so here's where we kind of put it all together. This is going to take practice, and this is going to take work on your own to really get good at it. So what we're asked now is to find the trig functions of certain angles. What we need to remember on these is that sine is y, cosine is x. If you don't remember these, go back to the beginning of the video. It's why we explain why this works. Tangent is y over x. So all they're asking us to do is find the x or y values of each of these angles. Now, some of these are easier than others. If you have your unit circle in front of you, you can figure it out. You just have to go to that angle, pick out the x or the y value, and you're done. However, if we were to be in class and be working on this, these are things I'd expect you to be able to do without looking at the unit circle. And I don't want you to draw it out either. So here's what we're going to do to figure this out. We have to use our reference angles. So 135, the first question here is this, we're looking for the sine of 135 degrees. This happens in quadrant 2. I'm going to sketch that out for you. So 135 degrees is right over here, and it looks like this. Okay, what we want to know, since we're looking for sine, we want to know the y value of 135 degrees. Well, I'm not asking you guys to memorize the angles outside of the first quadrant, only the first quadrant. So we have to ask ourselves, what is the reference angle of 135 degrees? The reference angle of 135 degrees, the distance from 135 to 180, is 45 degrees. So if we know the y value of 45 degrees, we're going to know the y value of 135 degrees. They're the same. So 45 degrees, that's the one we figured out, is the square root of 2 over 2. Again, check out that left-hand trick because that'll make it super easy to figure these out without looking at the unit circle. The only other piece we have to consider then is what's the sine, S-I-G-N, here at 135 degrees? Well, quadrant 2, my y value, we've gone up, so I know that the y is going to be positive. So my answer of the square root of 2 over 2 is correct. Okay, let's take a look at another one. Here we've got the secant of 180 degrees. Well, secant goes with cosine. So what they're asking me for is really the cosine of 180 degrees, and then I'm just going to put that under 1. That's how I figured that out. So what I'm going to do is draw my unit circle. I'm going to draw it out here. 180 degrees is right over here, all the way around. The nice thing about 180 degrees is it falls right on an axis, so it makes it easy. The point there is -1, 0. It's negative because I went to the left, and then I didn't go up or down at all. So I know my coordinate for 180 degrees on the unit circle is -1, 0. The cosine value that goes with this point is the x value. Cosine is x. Okay, so the cosine of 180 degrees is -1. That's the x value. But it's not asking for the x value. It's not asking for the cosine. It's asking for the secant. So what I really have to do is say the secant of 180 degrees is actually 1 over -1. Luckily, that just ends up being -1. All right, next one is cotangent of -300. Now remember, tangent is sine over cosine. Sine over cosine. So cotangent is going to be the reciprocal 1 over that, or cosine over sine. So to find this trig function, I have to know not just one of the two, but I have to know both sine and cosine. So let's figure it out. So here's my coordinate plane. If I went all the way around the circle, remember going this way because it's negative. If I went all the way around the circle, it'd be 360 degrees. So -300 degrees is going to leave me 60 degrees shy of that full circle. So it's kind of nice in trying to draw this. Not only have I drawn it accurately, but I also found what that reference angle is. That's my 60 degrees. 60 degrees is the reference angle. So now what I can do is actually find this point. Now, from what we built before, 60 degrees has a cosine of 1/2 and a sine of the square root of 3 over 2. Again, The y value, that's a longer leg than my x value, because this is pointing a little more up and down than if I were to be over at 30 degrees. That would be more over here. So it makes sense that my y value is bigger than my x value. So to find the cotan, I'm going to take the cosine, which is the x value, and I'm going to put it over the sine value. Keep, change, flip. I have 1/2 times 2 over the square root of 3. The 2's cancel, and I'm left with 1 over the square root of 3, but I have to make sure to rationalize that. So I end up with the square root of 3 over 3. If you need me to show you how to rationalize that, just give me a shout out. Okay, so now I've gone through 3 examples. If you feel like you're good, if you feel like you're getting it, then go ahead and pause this video, see if you can do the rest of these problems, and then go to the end and check your work. I'm going to go through the rest of them, these 9. So stick with me if you want, and I'll continue to show you my process of figuring out how to do these. All right, so number 14 here, we've got the cosecant of 120 degrees. So cosecant we know goes with sine. So that's going to be our y value. And 120 degrees is going to be over in quadrant 2. So let's sketch that first. So here is 120 degrees. The way to figure out what this angle is, or what the coordinates are here, is to know the reference angle. So the reference angle of 120 degrees is 60 degrees. That's what it's going to take to add up to 180. So if I know the coordinates of 60 degrees in quadrant 1, I can figure out the coordinates of 120 degrees. 60 degrees, the x is shorter than the y. So we've got 1/2 square root of 3 over 2. Those are my coordinates for 60 degrees. We're looking for the sine value, or the y value. So the sine of 60 degrees is the square root of 3 over 2. Just so happens that the sine of 120 is exactly the same because they are both in the positive y direction. They're both up. Now, but we're not looking for sine. We're looking for the cosecant of 120, which means we're going to take the sine of 120 and put it over 1. Keep, change, flip. 1 times 2 over the square root of 3, which means I now have to rationalize it. So I'm going to multiply both sides by the square root of 3 over 3, both the top and bottom, numerator and denominator. So I've got 2 square roots of 3. On the bottom, the square roots cancel out, and I'm left with 3. So the cosecant of 120 degrees is 2 square roots of 3 over 3. Onward. Number 15, the tangent of 270 degrees. Well, 270 is actually one of my quadrantal angles. So that means its coordinate is one of the easier ones to find. I haven't gone anywhere left or right, so my x value is 0. But I've gone down, so I know that I'm 1 unit away from the center in the negative direction, so my y value is -1. Tangent is sine over cosine, or y over x. So the sine here, my y value, is -1. The x value is 0. So that's my fraction, and then we know that anything divided by 0 is undefined. The tangent of 270 degrees is undefined. All right, number 16, cosine of -150 degrees. So the cosine, remember, is our x value. Let's figure out where 150 degrees is. So that's negative, so we're going to go in this direction. It's going to be in quadrant 3, just 30 degrees shy of that full -180. So right by sketching it out correctly, we've got that our reference angle is 30 degrees. Okay, so for 30 degrees, our x value is the square root of 3 over 2, and our y value is 1/2. Again, check out that left-hand trick to help you remember those nice and easily. Or you can say that the x is bigger than the y. So the cosine is my x value, the square root of 3 over 2. But All right, so let's write that in. The cosine of 30 degrees is the square root of 3 over 2. So we know the number for the cosine of negative 150. We know that the number is the square root of 3 over 2. But we have to check the sign. So negative 150 was over here, landed in quadrant 3. In quadrant 3, we're traveling to the left of the y-axis, so our x is negative. If the x is negative, that means that that cosine value is also going to be negative. So the cosine of negative 150 degrees is going to be negative the square root of 3 over 2. All right, 3 pi over 4. So now instead of talking about degrees, we're going to be talking about radians. We still just need to know those quadrant 1 values. We've got pi over 6, pi over 4, pi over 3. As long as we can find the reference angles of those, these reference angles for whatever angle we're talking about, we're fine. We can figure out those coordinates. So the cosine of 3 pi over 4. First thing we want to do is try to figure out where 3 pi over 4 is. And cosine, we're looking for x. 3 pi over 4. Well, all the way across takes us to pi. So 3 pi over 4, if we were talking about in terms of 4, that would be 4 pi over 4. That's the same as pi. And we're not quite there. 3 pi over 4 is less than 4 pi over 4. So we're going to be here in quadrant 2. But this is where it's really easy to find the reference angle. 3 pi over 4 has a reference angle of pi over 4. So as long as I know my coordinates for pi over 4, I'll be able to find my cosine for 3 pi over 4. So pi over 4, anything over 4 has those nice easy coordinates for us to remember because they're the same. Square root of 2 over 2, comma, square root of 2 over 2. The x value is my cosine, so I've got square root of 2 over 2. But because the angle we're actually looking for, this 3 pi over 4, is in quadrant 2 and to the left of the y-axis, that has to mean that my final answer for cosine is actually negative square root of 2 over 2 because it's to the left. All right, number 18 is tangent of 2 pi over 3. So tangent, remember, is sine over cosine, so we're going to make sure we find both. 2 pi over 3. Remember, we've got 1 pi over 3 here, 2 pi over 3 here, and then 3 pi over 3 takes us all the way over to, that simplifies down to pi. So the tan of 2 pi over 3 has a reference angle of pi over 3. So if I know my coordinates for pi over 3 or 60 degrees, same thing, I know the coordinates for 2 pi over 3. So pi over 3, 1/2, square root of 3 over 2. That is sine over cosine. So I'm going to take my sine value, square root of 3 over 2, put it over the cosine value, keep change flip, square root of 3 over 2 times 2 over 1. The 2's cancel, I'm left with the square root of 3. But in quadrant 2, the x values are negative. My cosine is technically negative, negative 1/2, negative 2 over 1. So if I'm multiplying or dividing by one negative number, positive divided by a negative is actually a negative. So the tangent of 2 pi over 3 is going to be negative the square root of 3. And that's your final answer. Number 19, cotangent of pi over 2. So that's, we know that tan is sine over cosine. So cotan is going to be cosine over sine. Those are the reciprocal functions. So pi over 2 is my quadrantal angle, 0, 1. That's the one that's easy to find. So cosine is the x value, which is the 0, over sine, which is the y value. So when we divide 0 by 1, we just end up with 0. We're good because the 0 is in the numerator. If it was in the denominator, if the 0 is in the denominator, then it would be undefined. All right, last three, you guys, home stretch. So the secant of negative pi over 4. So secant goes with cosine, which is my x value. Negative pi over 4. So we know we're going in this direction. Pi over 4 splits that quadrant in half. The nice thing about a negative angle in quadrant 4 is that the reference angle is exactly the same in quadrant 1. So what was negative pi over 4, our reference angle is just pi over 4. The coordinates for pi over 4 were the square root of 2 over 2, square root of 2 over 2, but because our actual angle is down in quadrant 4, our y value is going to be negative. So those are the coordinates for negative pi over 4. In this case, it doesn't matter though, because we're looking for cosine, which is the x value. So the cosine of negative pi over 4 is the square root of 2 over 2. But since we're looking for the secant, we're going to flip it to give us 2 over the square root of 2. Then we rationalize. 2 square roots of 2 over 2. The 2's cancel, and our final answer, I'm running out of room, is just the square root of 2. Okay, tangent of 5 pi over 4. Remember tangent, we're going to do sine over cosine. So 5 pi over 4. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 5 pi over 4. 5 pi over 4 takes me over here. Anytime it's an over 4, we know that our reference angle is pi over 4. So this is our full 5 pi over 4 angle. The coordinates for pi over 4, again, square root of 2 over 2, square root of 2 over 2. Over 2. So for 5 pi over 4, though, both of those are going to be negative. We've gone to the left, so our x is negative, and we've gone down, so our y is also negative. What we also know is that if we remember the acronym all students take calculus, we know right away that tangent is the only trig function that's positive in quadrant 3. So we can look at it that both the sine and the cosine are negative, or we can just forget about it and remember that if we're talking about tangent, it's going to be positive in quadrant 3. So the tan, I'm going to take my y value and put it over my x value. So the tangent is the square root of 2 over 2 over the square root of 2 over 2. I'm dividing the same thing by itself. My answer is just 1. Last one. I've got the cosecant of negative 5 pi over 6. Cosecant goes with sine, and negative 5 pi over 6 has a reference angle of pi over 6. So those are the two pieces that I need to find. So pi over 6 would be right here, and that has the coordinates of the square root of 3 over 2, comma 1/2. So if we're looking for sine, we're looking for the y value. That's what we're working with, 1/2. For negative 5 pi over 6, that's just shy of the 180-degree mark, or the pi. So the y is actually going down. So we know that that's negative 1/2 is the sine of negative 5 pi over 6. But we're not looking for sine, we're looking for cosecant. So the cosecant is actually 1 over negative 1/2. Keep change flip. 1 times negative 2 over 1 to give us a final answer of negative 2. Good job hanging with me, you guys. That was a long video, lots of problems. Like I said, this is just going to take practice on your part. Watch the video on the left-hand trick. Rewatch this. Send me any questions if you have them. This, like I said, it just takes practice. Make sure you're really good at your reference angles. Make sure you're really good at figuring out the 30, 60, 90, sorry, 30, 45, 60, using your special triangles. Have those coordinates for quadrant 1 memorized, and it will make everything a lot easier. Thanks so much for hanging in. Shoot me any questions you have, and I will be seeing you guys soon. Take care. Bye.